Okay, good evening everyone. So I'll discuss about weather, season and climate. Most of the time many of us use these words interchangeably, which is not appropriate. All these terms are different on temporal scale, or in a simple language, like we use these terms for different time periods. I'll explain how. What are the controlling factors which define these three phenomena, and the variation of climate in Uttarakhand. Okay, so the climate, this phenomena, where the weather, season, or climate, it works in atmosphere of Earth. You see this blue region, I'm highlighting using the pen. This blue region, it represents atmosphere of Earth. And our atmosphere has different layers, starting from the troposphere near to Earth's surface, then stratosphere, then mesosphere, and then thermosphere. When we are traveling from a flight, we see it's like a layer of clouds. It's a tropopause, upper limit of troposphere. You see the tropopause, which is about at 12 kilometer above mean sea level. Then we have stratosphere, then mesosphere. The ozone layer, whose depletion is responsible for the influx of UV rays on the surface of Earth. It is like accumulating in stratosphere, and the greenhouse gases which are responsible for the depletion react with the ozone layer in the stratosphere. So different atmospheric layers have different temperature and pressure gradient, and the variability of these temperature and pressure in each layer is responsible for the atmospheric dynamics. It's a complex phenomena, but in this presentation we will try to understand in a simpler manner. Through these three plots, we will try to understand the differences. Let's start with this horizontal scale. When we are trying to define the variation of temperature and rainfall for days, for like 1 day or 2 day or 3 day or even 7 or 8 days, we should use the word weather. For example, today it's raining, so it's a weather. Or like for the next 3 days, it's going to rain, so weather is rainy. But the same thing when we use for months, for example, in Indian summer monsoon season, if I say from July to September, it will rain in North India. So I'm talking about the rainy season. I'm not saying rainy weather. It's a season. It's a well-defined phenomena occurring every year during these months. And then for years, if I'm talking about 1 year, 2 year, 3 year, 5 years, for example, in these 5 years the rainfall was relatively less in comparison to the like past decade, not even past decade, like past 5 years, 6 years. So I'm talking about a part of a climatic cycle, because climate is occurring in a cyclic manner. Warm climate, I mean increasing temperature, decreasing temperature, you will see the curve. And then the word climate we use for a longer time period, for 30, 40 years, 3, 4 decades. So the variation in years is a part of its long climatic cycle. Okay, so this plot where we are trying to show the monthly variation in rainfall is actually for to highlight the seasonal variation. You see, from January to December, there's a variation in rainfall having maximum in June, then July, and then depleting. So this is a typical example of summer monsoon season of India. The data belongs to Uttarakhand. Its average rainfall uh, took for a duration of 1980 until 2022. Then on the right side, we have variation of temperature from 1880 until 2020. I have given the references here on the right side. You see, post 1980, the temperature is increasing, and during 1980 until 2020, it has increased 1 degree. So now we will use the word climate, that in the last 4 decades, the temperature has increased 1 degree. So it's a climatic variation. It's not a weather or season, it's climate. Okay, now what are the controlling factors of climate? The first one is Earth teleconnection. El Nino Southern Oscillation. It's a phenomena which occurs in Southern Pacific, affecting the climate, not the climate, part of climatic cycle. between South America and Western Australia. This phenomena also affects Indian summer monsoon, Indian Ocean dipole, and there are research happening in different laboratories, in different universities, finding the interconnectedness of these teleconnections because these phenomena involve ocean as well as atmosphere. So something which is happening in Pacific might also affect Atlantic Ocean. The second phenomenon is North Atlantic Oscillation. Again, a teleconnection occurring in the North Atlantic between Iceland Low and Azore High. Azore is at approximately 35° north latitude and Iceland about 65° north latitude. So 65 degrees is a range of low pressure zone, subpolar region, and 35° is a zone of high pressure. So this is the pressure difference between Azore High and Iceland Low, and this pressure difference in each 4-5 years or 6-7 years is responsible for the positive phase of North Atlantic Oscillation and negative phase of North Atlantic Oscillation. Again, the third one is Arctic Oscillation, up to some extent similar to the Arctic Oscillation. Many researchers say these are Arctic Oscillation and North Atlantic Oscillations are similar, but they do have some variations. Again, it's between Arctic region and the subtropical region. The variation between these two regions, the pressure difference. Then Indian Ocean dipole. This phenomena is occurring in Indian Ocean. The variation of sea surface temperature between Western Indian Ocean and Eastern Indian Ocean. Other factors are planetary factors like eccentricity, obliquity, precession, and solar storm. The first three are part of Milankovitch cycle, which which explains the variation of climate or variation of seasons on Earth. Eccentricity is change in the orbital path of Earth. Obliquity is change in the obliquity of Earth because our Earth is tilted with respect to the axis of rotation. And then precession, it's like bobbling. In India, in Hindi language, it's there's a tool which the children use to play. It's called lattu. So it's like bobbling. So precession is bobbling of Earth. This bobbling occurs due to uneven distribution of mass on Earth, and then obliquity, it occurs owing to the gravitational differences uh, between different forces. For example, the gravitational pull of moon, the gravitational pull of sun, the gravitational pull of Jupiter and certain other planets. Eccentricity again, the gravitational pull difference between uh, Jupiter, Saturn, and the Sun. It affects the path of orbit, like orbit path of Earth. Then anthropogenic forcing. The first one is greenhouse gas emission. Then the second one is land use change and deforestation. Third one is industries and transportation. We all know the first one, like the chlorofluorocarbons, which we release through fossil fuel burning, through our home appliances, which when it reaches in a stratosphere, it reacts with ozone and result in ozone depletion. The second is land use change for our need when the population is increasing. We are changing the surface. For example, if we have to make a hydropower plant in a mountainous region, so we have to submerge a land for a reservoir, and for that submerging process, we will lose the forest, we will lose agricultural land if situated near the river. We will lose, like in forest, we have different categories: dense forest, moderate forest. So it will, the making of reservoir will change the land use, and the deforestation is a part of it. So this change will affect uh, in a long term the climate of that region, because occurrence of reservoir will affect availability of moisture in that region. Availability of moisture in that region will affect the rainfall pattern in that region, and rainfall pattern in that region in longer term will affect the climate of that region. And then the change in climate will be responsible for different changes. Industries and transportation, again, the release of CO2 and other gases into atmosphere, ultimately leading to the depletion of ozone. And then the climate change and teleconnections in context of Uttarakhand. And the x-axis represents the temporal scale from 1982 until 2022. Then we have ENSO index, El Nino Southern Oscillation, the North Atlantic Oscillation, DMI is another name of Indian Ocean Dipole, then rainfall variation and surface runoff variation. I have used different color. For orange is used for non-monsoon month and blue for monsoon months. These gray bars represent anomaly in these plots. In general, there was a notion that a specific phase of ENSO or North Atlantic Oscillation or Indian Ocean Dipole is associated to the increase or decrease of rainfall or the temperature variation of a specific region. But in this finding, by the way, it's part of our ongoing research which will be out soon. So we are trying to show that the influence of El Nino Southern Oscillations, North Atlantic Oscillation, and Indian Ocean Dipole, there is no direct impact on the weather of Uttarakhand. There might be a certain level of affinity, but there is no direct relation. For example, in 2013, you see we have relatively high rainfall, and if we see the ENSO index, it's largely negative. But in case of, for example, 1989, we have again relatively high rainfall, but the El Nino Southern Oscillation is slightly positive. It's not negative, it's slightly positive. The same thing goes for North Atlantic Oscillation and Indian Ocean Dipole. There is no certainty of the specific phase of these teleconnections in the weather. Thank you so much. In the next lecture of climate, I will try to explain the potential causes of such variations and some other case studies of Uttarakhand. Thank you so much.